Hey, it's Caleb. If you like this video, be sure to subscribe.
Hey, what's up everybody? I'm on the opposite side today, which just feels weird. But anyways, we're going to be talking about data integrity. Alright, so what is data integrity? We talked about it a little bit in the last video, but this video is going to be going over it in more depth. Data integrity is just having correct data in your database. So when we're databasing, we don't want repeating values. We don't want incorrect values, and we don't want broken relationships between tables. For example, in the last video I gave the example, you have a table here, and this is the user table. This is weird writing like this. And then we have a table over here, and that is the sale table, which is where you sell products, for example. This is just an example. You can implement other examples, but this is just to illustrate my point. A sale is when a user buys product. That means a sale needs a user as the buyer. Otherwise, there's no sale. We can't have a sale if no one bought it. Does that make sense? That means the sale is dependent on the user, and we have a relationship. The user buys stuff. Stuff is bought by a user. This is known as a, can you see this? This is known as a relationship. Now, do keep in mind that the term relational database does not come from the word relationship. It comes from relations, which is the mathematical connection of sets, which we talked about that in an earlier video, but just don't get that confused. But relational database does have relationships between tables. So this, if for some reason this was broken, and now we have a sale that was bought by a user or no user. So for example, let's say this sale was bought by user with the ID of 7, okay? And then we have a user of ID of 7. So there's a connection. The sale was bought by the user of ID of 7, which points back to the user. Make sense? That's data integrity. But if this relationship is broken, and it says this sale was bought by the user with the ID of 7, and then this person is removed from the database, well, now this sale points to a table or a user that doesn't exist. And that might be practical in some sense to say that sale was bought by that user when he did exist. But for things that need to update consistently, we don't want that to happen. So that's an example of an integrity issue. So you want to keep that relationship to say, okay, well, we got rid of the user. We need to update the sales to say, well, either the person is deleted or also do something with the sales. So, yeah, sorry if that was a little confusing. Okay, so the three main types of data integrity. First one is entity integrity. We talked about entities in like one of the first few videos. An entity is anything we store data about. So we had the user to begin with. This is an entity. What it means by entity integrity is basically unique entities. When we have a user, we often give them IDs. This is known as a key. So an ID is used to enforce uniqueness among the entities. Like for example, if we had a table for users, and we store the name of the person, and then we stored their address. No, let's just go to their phone number. Yeah, sorry. Because when we talk about addresses, it's best to break it up into like street, state, and I don't want it to go through all that. So we could potentially have a person with a repeating name. So let's just say his name's Caleb, and his phone number is 1-800-YOU-WISH. Alright, well, if we had another person, if they both lived in the same house, for example, and this was their house phone, well, sometimes people name their children the same name as them. So now we have two people with the same phone number. And you look at this and you say, okay, well either we have two people with the same phone number, or we have two rows talking about the same person. And we don't know, because we don't have proper data integrity. So a way to solve this is to either add more columns to where the row would be unique, such as a social security number, or we could add an ID column, and this would be like 6 and 7. So now we're talking about two separate entities. This is talking about this guy because his ID is 7. This one is talking about this guy because his ID is 6. They're two separate entities. That's entity integrity, having uniqueness among your entities. We have uniqueness with the rows, and we also have only one user table. We're not going to have another user table because that information should go in the original user table. On to referential integrity. This is the one we talked about earlier, is when we reference the ID of a table in another table. If we had a comments table on the website, right? And we say who the comment is by, we have a user ID which points back to this ID over here. That's because the comment has to be posted by a user. Otherwise, we have a comment that didn't have someone who posted it, which doesn't make sense in the practical world. So we always have to have referential integrity, which basically says every time there's a comment, there needs to be a person who posted that comment. And that connection needs to remain. It needs to stay. If for some reason this is disconnected, and then this user is removed, or this table is changed, well then this could change. I mean, this stays the same, and then there's a disconnection to where this is changed, and this is old, outdated data, where either the user no longer exists, and the comment still says he does, or something else like that. That's referential integrity. And that'll make more sense once we start designing and stuff. But yeah. Domain integrity, that brings up a new word, domain. Domain is basically just the acceptable values for a column, per se. It's what we are storing, the range of what we are storing within a database. So when we're talking about tables, we have columns. So these columns up here, let's say we have a phone number. Well, that means we should have a certain number of digits. We have the area code, and then the 3 digits, and then the 4 digits. And that's at least the US. It might change other places. But that is 10 digits. So we know that the phone number should be 10 digits, and it should be numbers. So if for some reason I put the word cake in the phone number column, well, for one, this is going to cause an error if we have domain integrity, because it's not a 10-digit number. It's just a word. That's not the proper domain. It's not a digit, it's not numbers, and it's not 10 of them. So we know that's going to cause an error. So that's the basics of data integrity. When we don't have data integrity, we have errors. When we have data integrity, we do something to correct those errors, such as saying, oh, these all need to be numbers. That's how we implement data integrity, by setting database rules. And how you do that with the database, well, that kind of varies upon the relational database management system that you use. Some relational database management systems allow for general rules saying, okay, this has to be a range of this numbers. Some of them are more vague, where they only allow you to implement data types. Data types would be like integer 10 digits. So when we talk about practically implementing data integrity, different relational database management systems have different things you can do. almost every single relational database system that I know of, I'm pretty sure all of them, but who knows, they allow for data types. So a data type is pretty self-explanatory. It's the type of data. So in database, we classify things as generally integer or text or date. So we either have numbers, text, or dates. That's like 3 general categories, which we'll be talking about that more in a future video. But the data type can put limits on what we're allowed to store. For example, we can say, okay, we only want a character column with the maximum of 20 characters. That means we can put a string in the column that says, I like pizza, yeah! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That'll fit. But if I wanted to change this pizza to lasagna, well then I just added a couple extra characters. That might cut it off. I'm not sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's the maximum we could put in that data type. That's an example of implementing that data integrity for the characters. So this will be for the domain integrity. We can also have referential integrity with what's known as foreign key constraints, which allows us to connect tables. Because when we draw tables, we could say that they're connected in some way. But how do we enforce that in a database? We use foreign key constraints. For example, we can say if this is the parent, let's say this is the users, and this is the comments. The user places a comment. So this is the parent, this is the child, because the child can't exist without the parent. You can't have a comment without a commenter. Well, using foreign key constraints, we can say, alright, if this user gets removed, also remove all of the comments by this user. That's an example of foreign key constraint. As for the non-repeating data, that is done with just designing your database in the best way. So yeah, I know that video was kind of jumped back and forth from concept to concept and maybe a little confusing, but I'm sure you'll get it as time goes on. So yeah, that's all I have to say in this video. Thank you for watching. If you liked it, please be sure to subscribe and click like. And share it to your friends on Facebook or Twitter or Google Plus or, yeah, that's all I know. LinkedIn, yeah.